Okay, so now that we know how to find the 6 trig function values using a right triangle, and we also know how to lay a right triangle on a circle, and we've had relationships for our 6 trig function values using the unit circle, let's start moving towards what we call our special right triangles and our special trig function values. Now again, why are we going to focus on 30, 45, and 60 is because these are the angles that come up more frequently than other angles when you're working in the real world. Now that doesn't mean that you don't have other angles. These are angles that come up more frequently, and they also can be used as reference points when you're trying to do calculations quickly. And keep in mind, this is almost like your multiplications tables, that you know that the sine of 30 degrees is 1/2. So I just want to give you a really quick background on these special right triangles. When you were in geometry, you had a 30, 60, 90 triangle. And what you should have learned in that special relationship between a 30, a 60, and 90 right triangle is opposite the 30-degree angle is what we call the short leg. Okay, adjacent to the 30-degree angle is what we call the long leg, and of course the hypotenuse is opposite the 90-degree angle. Well, if we call the short leg 1, and that's what this whole thing's built on, then the hypotenuse is 2 times whatever the short leg is, and the long leg is whatever the short leg is times the square root of 3. Okay, so what we end up with is the relationship 1, 2, square root of 3. It's very easy to remember, 1, 2, square root of 3. Now once we know that, we can do our calculations. The sine of 30 degrees, for example, is opposite over hypotenuse, or y over r, so it's 1/2. The cosine of 30 degrees is adjacent over hypotenuse, or square root of 3 over 2. The tangent of 30 degrees is 1 over the square root of 3, which can be simplified the square root of 3 over 3. Now taking the reciprocal of 1 over 2 would just be 2 over 1. So the cosecant of 30 degrees is 2. The secant of 30 degrees would be the square root of 3 over 2. Take its reciprocal, 2 over the square root of 3, which will simplify into 2 square root of 3 over 3. And the cotangent of 30 degrees is just the square root of 3. Now these are very important values that you start to learn. They're going to come up quite frequently in trig. 60 degrees, once again, all we did was just rotate our 30, 60, 90 triangle. Once again, opposite my 30-degree angle up here is my short leg. So once again, we have 1, 2, square root of 3. But since we've rotated our triangle, we now end up with our relationship. The sine of 60 degrees is the square root of 3 over 2. The cosine of 60 degrees is 1/2. The tangent of 60 degrees is the square root of 3. Now I'll take the reciprocals. The cosecant of 60 degrees is 2 square root of 3 over 3. The secant of 60 degrees is 2. The cotangent of 60 degrees is the square root of 3 over 2. Now notice something interesting here. Notice that the cosine of 60 degrees and the sine of 30 degrees are equal to each other. Cosine of 60 degrees is 1/2. Sine of 30 degrees is 1/2. And the reason why is because that CO in front of the sine stands for the complement of sine. So therefore, you could think about it this way. And again, I'm just trying to show this out to help you memorize these a little bit better. You could say that the cosine of 90 minus whatever my given angle is equal to the sine of my angle here. Okay? So for example, let's say our angle is 30 degrees. So this would be the cosine of 90 minus 30, which is 60, is equal to the sine of 30 degrees. Let's see if that's true. Cosine of 60 degrees is 1/2. Sine of 30 degrees is 1/2. So that's just an interesting little relationship. And the reason why is because 60 plus 30 is 90, so they are complements of each other. What about 45 degrees? Well, in a 45, 45, 90 triangle, we end up with 1, 1, square root of 2. So the sine of 45 degrees is 1 over the square root of 2. The cosine of 45 degrees is 1 over the square root of 2. And the tangent of 45 degrees is 1 over 1, or just 1. Now everybody loves 45 degrees because the sine and the cosine are equal to each other. The tangent and cotangent are both equal to each other, and the cosecant and secant are both equal to each other. Okay, again, these are just special right trig function values that you need to know. The next thing we needed to focus on is, we mentioned it in our last video, reference angles. And basically, what is a reference angle? Well, we're going to use that triangle, that 30-degree triangle now. If we laid it in quadrant 1, I could actually rotate it into quadrant 2, into quadrant 3, and into quadrant 4. And when I do that, for example, if I have a 30-degree triangle that I'm going to use in quadrant 2, well, imagine that I just basically laid a 30-degree triangle on the second quadrant, which means my right angle would be away from the origin. But what would be that angle, or theta? Well, it would be 180 degrees minus 30, or 150 degrees. Okay? So there are some special angles in each quadrant that correspond to a 30-degree triangle. Quadrant 1 is 30, quadrant 2 is 150, quadrant 3 is 210, quadrant 4 is 330. These are your special angles that correspond to a 30, 60, 90 triangle of a 30-degree angle. For 60 degrees, those 4 special angles in quadrant 1 is 60, quadrant 2 is 120, quadrant 3 is 240, and quadrant 4 is 300. These are your special angles that correspond to a 60-degree triangle. And your 45-degree triangle, you have 45 in quadrant 1, 135 in quadrant 2, 225 in quadrant 3, and 315 in quadrant 4. Okay? Now, what does that mean? Well, how do I calculate a reference angle? Well, if my given angle is theta, and we always want theta to be positive, we'll talk about that in a few minutes, then my reference angle, we're going to call alpha, can be calculated using one of these formulas. In quadrant 1, my reference angle is actually the given angle that we have. In quadrant 2, my reference angle is 180 minus my given angle. In quadrant 3, it's my given angle minus 180, and in quadrant 4, my reference angle is 360 minus the given angle. Okay? Now, how do we use that? Well, let's say, for example, I want to find the reference angle for 200 degrees, and that's not one of my special angles. So what am I going to do? 200 degrees is where? It's in quadrant 3. So I'm going to say 200 minus 180, so my reference angle would be 20 degrees. What if I was given an angle of 320 degrees? Well, again, 320 degrees would be in quadrant 4. Its formula says 360 minus theta. So 360 minus 320 is 40, so my reference angle would be 40. Now, taking a look at my last example here, negative 80 degrees. What I need is a positive coterminal angle, because these formulas will only work with positive given angles, okay? So I need positive given angles. So if I have a negative 80 degrees, I need a positive coterminal. I'm going to take 360 and subtract 80, which gives me 280 degrees. My reference angle then would be 360 minus 280, which is going to be 80. Now, it just worked out that way, and that makes sense because in quadrant 4, my negative 80 degrees would have a terminal side down here, and it would just be rotating in a clockwise fashion. But it would almost be like flipping this, where my reference angle would be almost the same thing as my given angle. However, since it's negative 80 degrees, we're in quadrant 4 and not quadrant 1. And remember, when we talk about our signs of our trig functions, that becomes important. So let's put all this together now in a series of steps. If we want to find exact trig function values, again, we're going to do all this work, and why do we want to guess at an answer? So step number 1 is to determine which quadrant that you're in for your given angle. Okay, step number 2 is what is the sign for that trig function. Step number 3, what is the reference angle if needed. Step number 4, draw that special right triangle if it is a special right triangle and if you need it. And step number 5, determine the exact trig value. So let's take a look at a few of these and see if we can do them. We're going to start off real simple. Now most of you could probably remember that the sine of 30 degrees is 1/2. But let's see if we can figure this out. Now the given angle is 30 degrees. That's theta. You see now we're not using A, B, or theta here. We're actually putting 30 degrees. Okay? Now the first thing we need to understand is where is 30 degrees. Now 30 degrees we have to know is in quadrant 1. It's right here. Okay? So 30 degrees is in quadrant 1. All right, in quadrant 1, the sign, positive or negative, for the sine function is positive. So this is just going to be equal to the sine of 30 degrees. Now what I need to do is draw my triangle. Okay, so I'm going to come over here. And it's good that you almost have these triangles memorized. 1, 2, square root of 3. And so the sine is opposite over hypotenuse, or y over r, so it's equal to 1/2. It's that simple. 1/2 is my exact value for the sine of 30 degrees. How about the cosine of 60 degrees? Again, I'm in quadrant 1, okay, because 60 degrees is between 0 and 90. In quadrant 1, cosine is positive, so we're going to say cosine is positive here. And this time, instead of drawing a 30-degree triangle, we'll draw a 60-degree triangle, so it's going to be 1, 2, square root of 3. The cosine of 60 degrees would be 1/2 as well, because it's adjacent over hypotenuse. What about the tangent of 60 degrees? Well, again, tangent in the first quadrant is also positive. So there's tangent of 60 degrees. I'm going to draw my 60-degree triangle again. Again, it's good that you memorize these. And again, make sure that your 1 is always opposite your 30-degree angle. Notice up here my 1 was my vertical side, and down here my 1 is my horizontal side. Okay? My tangent is opposite over adjacent, so it's just going to be the square root of 3. So there's my exact value. Again, these are all in the first quadrant. I tried to make it simple here so that we could go through these. So now I'm just going to draw my 30-degree triangle. 1, 2, square root of 3. The secant is what? A reciprocal of the cosine. Okay? So I got to know that. Cosine would be the square root of 3 over 2. So therefore, I know this is going to be 2 over the square root of 3, which becomes 2 square root of 3 over 3. Okay? Cotangent of 60 degrees, okay, cotangent is what? 60 degrees, so we're going to draw, okay, so we've got 1, 2, square root of 3. Cotangent would be 1 over the square root of 3, because it's going to be adjacent over hypotenuse, or x over y. I can't leave it like that. I get square root of 3 over 3. Cosecant of 45 degrees, 1, 1, square root of 2. Okay? And so now my cosecant is going to be the reciprocal of sine. Sine would be 1 over the square root of 2. So my cosecant is just going to be the reciprocal of that. See, I want to think of this as the sine of 45 degrees, which would be 1 over the square root of 2. But now the reciprocal of that would be what? I'm going to flip numerator and denominator, just be the square root of 2. Okay. So what happens if they're in other quadrants? So I've worked some of these out already just to speed up this video a little bit and help you out. But if you want to pause and take a look at what I've done, and then I've got some that I'm going to work here for you. We want to look at the sine of 150 degrees. Now again, let's go through our process. The quadrant that we're in this time is quadrant 2. The sine of my trig functions, well, I wrote this down. All students take classes, or all students take calculus, whichever way you want to decide to do it. And so since we're in quadrant 2, its sine is positive. So I put plus sine. Now where did I get this 30 degrees from? Is because of my reference angle. The given angle was 150 degrees. But remember, in quadrant 2, when we're trying to find a reference angle, what do? Quadrant 2, we're trying to find the reference angle. And so it's going to be 180 degrees minus my given angle, which is theta. So it would be 180 minus 150, which is 30 degrees. So the sine of 150 is equal to the positive sine of 30, which now, if I draw my triangle, there's 30, 1, 2, square root of 3, it's 1/2. Okay? So the quadrant, the sine of my function, the reference angle, and then step number 4, draw the triangle. So let's take a look at the sine of 240. Okay, 240 degrees. Let's walk through our process here. What quadrant are we in this time? Well, we're in quadrant 3. Okay, because 240 is between 180 and 270. All right. Step number 2 is to find the sine of my trig function value. So, once again, all students take classes. All right. In the third quadrant, tangent is positive. So that means that sine has to be negative. So I'm going to write negative sine. And now I need to find my reference angle. All right. So my reference angle is going to be found by doing what? It's going to be in the third quadrant. So the reference angle is going to be theta minus 180, which is going to be 240 minus 180, which is going to be 60 degrees. So my alpha, or my reference angle, is 60 degrees. So this becomes the negative sine of 60 degrees. So I need to draw a 60-degree triangle. 1, 2, square root of 3. My sine is opposite over hypotenuse, or y over r. So it's going to be negative square root of 3 over 2. Now some people will say, hey, what if I get square root of 3 over 2 and I forget the sine of it? Well, that's why we're going through all of this. Because when we get into double and half angle formulas and other applications of this, remember, this is like almost knowing your multiplication tables. It's important that you get the sine right. All right, take a look at number 9. Again, I've already done it for you. The tangent of 135 degrees is -1. And we're going to take a look at one more down here, cotangent of 315. So again, what quadrant am I in? Okay, I'm in quadrant 4. Okay, step number 2, what is the sine of my quadrant? All right, all students take classes. Okay, in quadrant 4, cosine is positive. We've got cotangent here, so we're going to be negative with our cotangent. And now I need my reference angle. Okay, how do I find that? Well, again, I'm in quadrant 4. Okay, in quadrant 4, my reference angle is 360 minus whatever the given angle is. In this case, it's 315. So my reference angle is going to be 360 minus 315, which is going to be 45 degrees. So it's going to be cotangent of 45 degrees. And now I draw my triangle 1, 1, square root of 2. Okay. Something might help you is always put your angle down here in the lower left-hand corner of the triangle. All right, and so cotangent would be adjacent over opposite, so it's just going to be -1. Sorry for everything kind of falling on top of each other. Remember, let's remember the process now. We've gone through a lot of information in these last few videos. Whenever you want to find trig exact values, you need to know what quadrant you're in. You need to determine the sine of your function. You want to find your reference angle for that. Draw the angle, draw the special right triangle if needed, and then determine the exact value. Good luck.